In section 7.2, we're going to learn how to find those probabilities that were magically given to us in section 7.1. And to do that, we're going to keep a close hand on this decision matrix. This will help us through the whole of section 7.2. And it's really confusing right now, but it actually will be really helpful as we go through these problems. So you want to keep it on hand. It was written for the TI-84. That's one thing to note. And yet again, StatCrunch is actually a little easier. But nevertheless, it can still help you even if you're using StatCrunch. And there are a bunch of different notes and caveats, and we'll go through these as we run into different problems. So just keep it with you. Now, it's actually in Appendix A as well. So it's going to be given to you, the whole thing, including all those notes, right on the exam. So you don't have to memorize any of this. You just have to know how to use it. Okay? All right, so before we can use it, of course, we have to learn some definitions. So the first definition is the standard normal distribution. Now, that's the distribution of z-scores. Remember z-scores? They're a measure of position from section 3.4. Remember I had Han Solo and Leia and all their heights and so on? The z-scores form their own normal curve. It's called the z-curve very commonly. Right? So z-curve right here. It has a mean of 0 right in the center and a standard deviation at the inflection points of 1. So your mean is 0, standard deviation is 1. So it goes 0, 1, 2, 3. Now, sometimes I'll put the letter z in there. Sometimes I won't, but you'll know it's a z-curve if you see the mean is 0 and the standard deviation is 1. And I don't even have to write it up here in order for you to know that. You can tell it just by looking at the curve. So it's called the z distribution, the standard normal distribution, the z-curve, any of those terms. All right, that's lovely. It's not too bad. It's just a normal curve. It's actually a really nice, powerful normal curve, but with having a mean of 0, that makes it nice and easy. And we're actually going to work with the z-curve frequently in chapters 8, 9, 10, and 11, especially 9, 10, and 11. We will see this curve again a lot. All right, now what about critical z values? Also something we're going to see in chapters 9, 10, and 11 a lot. So if you want to let yourself know, this is chapters 9, 10, and 11. We'll see these again, right? These critical z values. So this is not going to go away. This is going to be something you're going to have to do repeatedly. So it'll be important for you to know the definition. Now, there's z-scores, these critical z values. There's z-scores, which means, of course, they're on a z distribution that have a special significance, right, for chapter 9 onward. Z sub alpha. All right, so see how there's a z with a little subscript after it, little letter below it. That's alpha. That's the Greek letter that starts off the Greek alphabet. Looks like a fish, kind of, right? Like a sideways fish. So it's alpha. And it's because we ran out of letters. That's the reason I did this. All right, so Z alpha means that this area to the right is alpha. So let me highlight that. So area to the right is alpha. Right here, this is the area to the right. And that's alpha. That's called Z alpha. So for example, suppose that area to the right was 0.15, then this would be Z with a little 0.15 after it, right? It means that 0.15 is to the right. Now, what if it's negative Z alpha? That means that it's to the left, right? So positive Z alpha means to the right, negative Z alpha means to the left. So if you see, okay, this area right here, if that's alpha, then this line right here, that's what that line is. That's the Z alpha. These are Z values down here, right in here. Those are Z values. So this line right here is at positive Z alpha. This line right here is at negative Z alpha. For example, suppose that this alpha over here was 0.20. Then this would be negative Z with a little 0.20 subscript, below script. All right, so why don't we use those z-scores and we'll actually be able to find some probabilities, which is the next question or the next example. So now that we know what the z-scores are and the standard normal curve is and all that good stuff, right? And again, remember, z's are on this axis. Up here is areas, right? So in the curve is areas, down here is the z values. So we're going to put that to use right here for this example. So we want to find the area under the z-curve for all of these questions. All right, so if you look here, it says the probability that negative 1.35 is less than or equal to z, which is less than 1.62. Don't get worried about the less than versus less than or equal to. This is a continuous distribution, so it shouldn't matter at all which one you've got where. Okay, so remember the center of a z-curve is 0, always. So negative 1.35, well, the inflection point's at negative 1. Negative 1.35 would be, I don't know, here. I'm trying to draw that vertically. So this is z, which is negative 1.35. Then over here, at the inflection point's about 1. I'm at 1.62, so a little bit further away. That's z, that's 1.62. So those are two z-scores. Right? And what you want to know is the probability of being between the two z-scores. Right? That's what you're looking for. So let me see here. I'll go with blue. So I'm looking for the probability of being between those two z values. Those aren't subscripts, right? That's not what I'm doing here. Matter of fact, if it's getting confusing for you, just write negative 1.35 and positive 1.62. That's what we're talking about here. Make sure the 1.62 is farther away from 0 than the negative 1.35, right? But just a little bit. I want that area. I want that probability. I've shaded and labeled my curve appropriately, right? I have the negative over here, the positive over here. They're both past an inflection point, and the 1 is a little bit further away. Now, how am I going to find that area? All right, let's go back to the decision matrix. We already know z-scores. We know negative 1.35 and 1.62. What we want to find is the area, the probability, that blue zone I shaded. So we're going to use normal CDF, lower, upper, 0, and 1. All right, so again, that's a TI-84 step. Let me show it to you on StatCrunch as well, but let me start with the TI-84. So it'll be normal CDF, lower, comma, upper, comma, 0, comma, 1. That's what it said. Lower and upper, what are they talking about? Well, the lower is the lower end, right? The left boundary. And I actually wrote that right here in the notes. It's the left-hand boundary of your shaded area, and the upper is the right-hand boundary of your shaded area. So if we look at our shaded area, the lower boundary is negative 1.35, and the upper boundary is 1.62. Left and right, lower and upper. Now I know what you're thinking. Why is that lower when it's left? Well, because this is the z-axis. It's like the x-axis, right? Lower is on the left side, upper is on the right side. All right, so we just go type that into a calculator. Simple as that. So let me grab a calculator, clear all this out. So second distribution. It's in the distribution menu because this is a probability distribution. And if you see, number 2 says normal CDF. Okay, so we grab normal CDF. Lower. We just said the lower was negative 1.35. Oh, and you have to make sure you type the negative sign, which is down here with that little parentheses in it. Don't use the subtraction sign. Use the negative. So it's 1.35. Enter. The upper is the higher one, which is 1.62. And then, convenient for us, the mean is 0, standard deviation is 1, right? Because that's the most common curve. So then we press enter to paste it, and then we press enter again, and ta-da, it tells us that area is 0.8589 if we're rounding to 4 decimal places. Now, what about StatCrunch, which for my money is actually easier. So let me grab StatCrunch here. So under Stat, Calculators, you want to go for normal, which is right down, well, almost to the bottom. So 5 away, 6 away from the bottom. So Stat, Calculators, normal. All right, so you can see it's telling you, hey, I have the mean as 0, standard deviation is 1. That's convenient. We're looking for a between. So we actually want to click on the between because we want it to have one number on one side and one number on the other side. I mean, it should look like we shaded it on the paper. So I just typed negative 1.35, positive 1.62. I mean, you can see it's less than or equal to x, which is less than or equal to, I mean, it looks just like it does on the page. And I pressed enter or compute, and it tells me it's 0.8589, which is the answer we got out of the calculator. And also it draws it for me. Just in case I was worried I hadn't shaded it correctly, I can see the shading right here in StatCrunch, and it matches what I did on the paper. So isn't StatCrunch awesome? It's really easy to use. All right, so for StatCrunch, I just wrote a little note down here at the bottom of my decision matrix, what I'm using, stat, calculators, normal. And away you go. All right, so let's keep practicing. What about the probability that x is greater than 1.14? Okay, so remember, here's 0. The inflection point is at 1, so 1.14 would be just a little bit past there. There's 1.14. It's a z-value in case you're interested. All right, if I want to be greater than, I want to go to the right and shade to the right. Okay, so let's look at this on StatCrunch first because it's going to be much easier on StatCrunch. This is not a between probability. I don't have two numbers here. So I'm actually going to switch to standard. I click on the little standard. Mean is 0, standard deviation is 1. Fabulous. I want the number 1.14, but I want it to be greater than. So I'm going to click on the little less than symbol and pull down to the greater than. And there you can see it shaded just like we have on the page. And it tells us it's 0.1271. Wonderful. Now, if you want to use the calculator, how do you get to the same value? Well, calculator is going to be a little bit trickier. So we know we want to find an area, to find a probability given a z-score. So it's still going to be normal CDF, lower, upper, 0, and 1. Right? We haven't used anything else yet, nor will we for a while, actually. All right, so normal CDF, lower, upper, 0, 1. And we actually know the answer now because we did StatCrunch. StatCrunch told us it's 0.1271, so therefore I know this is 0.1271. And if you use StatCrunch, you don't have to show the calculator thing. That's your choice. But I just want to show people that if they want to use the calculator, this is what you do. The lower bound, the left-hand edge of what we shaded is 1.14. The trick is the upper bound. See, this little thing, this little normal curve goes on forever. Remember how I said there are arrows? So I need something that's going to stand in the place of infinity, right? Infinity is how far I want this to go. But the calculator doesn't have infinity. Now you'll notice what I said to do right here. If you're going to do a shaded right tail in normal CDF, you use 1E99 for that upper right boundary. So we're going to use 1E99. That's 1 followed by 99 zeros. It's scientific notation because we don't want to deal with this infinity. There is no infinity in our calculator. All right, so let me go grab normal CDF again. I want to say 1.14. And now where is that E? That E is above your comma button. So if you see the EE in blue? So you say 1 and then second, that blue button, and then see the comma? It says EE, but when you press it, it just does E because it's scientific notation. It's times 10 to the, right? That's our infinity, if you will. 0 and 1 is fine, so I'll click enter for paste and press enter. And lo and behold, I have the same answer that I had when I did StatCrunch. Nice, huh? All right, so again, you might want to make a note, right? To get that E, it's scientific notation. And you get that by the second button and then the comma button. And it looks like EE on the calculator. Right? Of course, if you're using StatCrunch, you don't have to bother with any of this. StatCrunch takes care of it, which is beautiful. Okay, now what about the percentile rank of z equals 1.89? Okay, so 0 is right here, 1.89. Remember, the inflection point's at 1, so that's kind of a mark right down here. That means that 2 would be right about there because it's got to have even spacing. So 1.89 would be, I don't know, somewhere in there. You just want to eyeball it in a reasonable way, right? You don't want to make it too close to 0, too far away. That's about where it should look like. Now, percentile rank, we haven't seen that in a while. That was from chapter 3 again. It was section 3.4, as a matter of fact. It's the percentage below you, right? At or below your score, remember? Okay, so what I'm looking for is the percentage below, so I'm looking for this area down here, the area to the left of that z-score. Okay, well, to find that area, again, it's normal CDF. That's all we know how to use so far. So normal CDF, left or lower, comma, upper, comma, 0, comma, 1. All right, well, the upper edge of what I shaded is 1.89. The lower edge is negative infinity, right? So I used negative 1e99, which again was written out for you right in the notes of the decision matrix. It tells you right there, right? Negative 1e99 for a lower left boundary, right? If you're shading the left tail, which we are right here, that's shading the left tail. So we'll use negative 1e99. And if you're thinking this will be easier in StatCrunch, you would be correct, but that's all right. So second distribution, normal CDF, little negative sign, that's where you grab it. It's that one in the parentheses. 1 second comma 99, and then 1.89. Enter. Enter, 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 get to paste, press enter, and there you have it. It's 0.9076, which should not be any great surprise because, I mean, look at how much of that curve we've shaded. Now, that's not the answer, so I'm not going to circle it. The answer, percentiles, we round. So we're actually going to say this is the 97th percentile. If you remember the notation for it from section 3.4, it was P with a little 97 after it. So either way you want to say it. Now in StatCrunch, it's even easier. Let me go to StatCrunch real quick. 0 and 1 is fine. I had 1.89, so I'll put 1.89 in here. I'm going to click the less than button, and there you have it, 0.9076. Done. All right, last one is a little tricky. This is the only one that's tricky kind of in both of them, which is the proportion of scores that fall outside, and that's key, outside of negative 2.1 and positive 1.3. Okay, so there's 1, so 1.3 is about here. Here's negative 1, so negative 2 is right here, negative 2.1, I don't know, it's right there. So I want to be over here in this zone. Ooh, I'll highlight it in orange. Here, I'll do orange over here, and I'll do blue over here. If you're going to be outside, that means that you need to be in one of those two zones. Okay, well, that's going to be a little tricky. You can find each of them separately and add them. So you could find each one individually and add them, but there's an easier way. So the easier way is to find the middle and then take it away from 1. Right? Use the complement rule. Complement rule. In other words, find that area in the center. So using normal CDF, the lower is negative 2.1, the upper is 1.3, 0 and 1. Find that, or find it with StatCrunch, and take it away from 1. If you find this area in the middle, then the area, the proportion that falls outside of that, which is the orange and the blue part to put together, you will have figured out. So either you find the two separate pieces and add them, or you find the middle piece and subtract from 1. All right, let me find this with the calculator quickly. So second distribution, normal CDF, I'm going to type negative 2.1, positive 1.3, 0 and 1 is fine. And I'll click paste. All right, so 0.8853. So this is 1 minus 0.8853. And then I'll just have the calculator figure that out for me. 1 minus 0.8853 is 0.1147. Or if you want to write it as a percent, 11.47%. Now in StatCrunch, this is the one problem in StatCrunch that is tricky no matter which way you do it. So it's definitely a between probability. So I'll click on between and I'll type negative 2.1 and positive 1.3, enter. And it finds the 0.8853, and then I would just have to take it away from 1 in order to be able to find that probability. So it does involve an extra step even in StatCrunch. And notice really quickly that I mentioned that you have to highlight, I'm highlighting it, that I mentioned that you have to round your percentile rank, right, to the nearest whole number, which is why I made that 97 rather than circling the 0.9706, which wasn't actually the answer for that particular question.